Welcome, everybody, to the Energy Suite podcast. I'm glad to have you with us today. No matter where you're listening in around the globe, it's really exciting. We have crested 17 countries now and getting close to 900,000 listeners around the globe. So it's always great. So I always remind people as you are dialing into these or listening in or watching on the video platforms to like, share, and subscribe because that makes that you don't miss out on any particular new episodes or updates. A little bit of house cleaning before we get started today. We want to thank our partners and sponsors, our good friends over at Smart Energy Solutions and leading energy transition with their optimizer technology. It's really good stuff. So glad to have them on board as a partner, our friends at Tax Hive. So if you're in the United States and you do need tax consulting and planning around your assets and your renewables, we recommend you get in touch with our friends over at Tax Hive. So with that out of the way, I'm really excited today to introduce a guest. And, here at the Energy Suite, we talk a lot about everything energy. And sometimes there's technologies that are not what be obvious to everyone of how they fit into the energy ecosystem. And today, this product and this great story might be one of those, but I'm going to spin it back in because it's actually very, very important. And so without any further ado, I'd like to welcome to the Energy Sweet podcast, Mr. Stuart Graham. He's the CEO and founder of Coat Zone. And so it's fun today. Whenever I catch up with Stuart, it's kind of like that old book, Where's Waldo? I have to find out where he is because the guy's a global traveler. He's checking in today from the Philippines. So glad to have you. So, Stuart, welcome.
Thank you, Rex. Very happy to be here. Looking forward to our chat.
Yeah. So, real brief, let's just a quick high level introduction. Well, no, let's take the normal route. Um, I introduced you as Coat Zone, and if people are listening and following along, you can quickly go to his website, coatzone.com. Okay. And they have some great technology that help in protecting of assets and heat reduction. And that's a big element what we're going to talk today. But before we get there, what I like to always do, Stuart, is and our listeners know that are regular listeners, that we always tell the story behind these technologies and the companies. So what I'd like to do is go back in time. Now, this doesn't have to be, I was born, on this date in this specific place and stuff.
Yeah.
But what I'd like to go back is to find out where were you born? What was your education like? Were there things in your upbringing that influenced you to get where you today? Maybe a little bit about your education, and maybe some of your education is just real world. And then also, too, just some hops along the way that helped you get to where you are today with Code Zone. And what I always like to share with people is we're not just technologies. I'm a technologist. There's a story behind all of this, and that's the human side of this. So take us back, Stuart. Where did this story begin? Where were you born? And tell us a little bit about your family and your upbringing.
Well, quite a strange story and a very long journey. So, I was actually born in a little town in Northern Ireland called Newtownards, which is just very close to Belfast, the capital of Northern Ireland.
Okay.
And I was born in a very poor family. We lived in a little homestead, but it was likely the happiest years of my life growing up there. I was a twin. I have a twin brother. So we were able to especially play soccer together. That was one of my passions and ended up playing soccer for quite a while. Um, I was educated in primary school to begin with, then went to a grammar school. I was fortunate to qualify to go there, and then eventually went to Queen's University, which is the top university in Northern Ireland. And of all subjects, I took the subject was history, not very related to what I do now, but my thought was initially, well, maybe I'll become a teacher or something. So history was my major. I graduated from university and became involved in financial services. I had a friend who introduced me, And that was my primary business in Northern Ireland. And unfortunately, whenever I lived in Northern Ireland, it wasn't the place you would really want to live in because we were in the middle of a civil war. So after being in a building that was blown up once, being carjacked once, I decided it was perhaps time to move on. So I ended up moving to California in 1991 and arrived there and thought, what am I going to do? Because I had no idea what I could do in in California in San Diego. So I I looked around and noticed how many people eat out in America compared with Ireland. And I thought I could maybe build a business around that. So I ended up starting a dining membership, which was a discount dining membership where you get 20% off your meal. And I thought, well, will this really work? Because in San Diego, where I lived, there were six other dining memberships, and I discovered they were all owned by one company. So they were just competing amongst themselves, which was a very good strategy from
Yeah,
their
not
side.
bad.
Very smart, very smart. So I would position it differently. So I went to the local newspaper, the San Diego Union Tribune, and basically said, look, guys, you guys tried to sell subscriptions. It was very difficult to sell a subscription. And most subscriptions are very short, 3 months. How about you offer our dining membership for people who will subscribe for 12 months? Because they discovered if someone subscribed for 12 months, they were more likely to stick with the subscription.
Sure.
So they said, yeah, we'll give it a whirl, which they did. And it became very, very successful. We ended up selling them about 250,000 memberships. And from there, it blossomed to newspapers all over the United States. Then we sort of diversified into public broadcasting. You give a donation to public broadcasting, you get one of our memberships. Then we went to banks. We ended up with a nationwide program with TD Bank up in Canada and a few other banks here locally. Built the company to where we had about 8,500 restaurants participating, plus lots of other merchants, about over 3 million members.
Wow.
And after about 10 years, we ended up selling the company. But it was a very, very interesting, fun ride. And after I sold it, during that time, I wrote a book called The Loyalty Myth, which you can still get.
Oh, wow.
Um, and the book sort of introduced me to a lot of interesting people. I ended up doing consulting work with a bunch of companies who wanted to develop loyalty programs. So I did that. And then in 2010, a very good friend of mine, another Irishman, called me and said, hey, I'm the COO of a solar finance company, and this was in San Diego. He previously was the CIO of a $3 billion company that went public, so he did pretty well on the deal. He called me and said, hey, we need your help. I said, my help? Solar? I wouldn't know a solar panel if it hit me on the head. I said, that would be a waste of time. Anyway, he invited me to their office in La Jolla. I went in, met him and the CEO, and they said, look, we would like help building our sales team and developing customer relations. So I said, okay, well, I'll give it a whirl, and did that for about 3 months. And whenever I first went in, they had about 100 people working on it. I said, how many sales have you got? And they said, none. I said, what? You've 100, and they had 20 people in accounting. I said, what are they accounting for? I won't mention the name of the company because it would be
That's fine.
embarrassing.
Yeah.
But anyway, I basically said, look, they had all these telemarketing salespeople. I said, you're wasting your time. Bottom line is that's how I got involved initially in the solar industry, and I ended up because they had a small operation in Hawaii, moving to Hawaii in about 2012. We actually took the company from about zero to 100 million in a year, but
Wow.
I did tell my friend to get out because I felt that there were some holes, shall we say, in the system where maybe there wouldn't be a lot of longevity there. But anyway, that's how I became involved in the solar industry, the energy world. A friend of mine then in California called me and said, "Hey, Stuart, I've seen this technology. I know the guys who have it. You should maybe take a look at it. It's to do with coating for air conditioning and stuff like this." And I said, "Well, that sounds interesting." So I flew to California, met with these guys, and ended up putting a deal together with them, but later discovering they didn't own the technology. So I ended up meeting the guy who is now my one of my partners, the CTO of CodeZone, Russell McNeese, who is also the inventor of the process,
Okay.
and met with him and met with another gentleman who was interested in the technology, called Nabil, who is my third partner. He's from Saudi Arabia. And we ended up deciding that we would actually buy out all the formulas for the products, which we did. And in 2019, we actually formed CoatZone. But the
Okay.
products themselves had been used by Russell for about, oh, now 17 years.
Wow.
So that's how the whole thing came about. The products, they've all gone through very rigorous testing, ASTM, ISO, UL testing.
Right.
But we decided we had to buy the formula in order to secure the business. And initially, the business was just in Houston, Texas, which is where Russell is. He has a large coating center there. But since that time, we have sort of taken it to many different countries, as you know.
Yeah, absolutely. Well, that's fascinating. I mean, starting out, I understand. I got to go back to this for just a hot second. I understand this soccer addiction still continues. Is that true? I hear rumors that you still get out on the pitch.
I still play soccer. Yes, I still play actually in Hawaii. I'm 73 years of age, but I play in the over 45 league and still able to score goals and play the game. And then I normally play a few international tournaments each year. So
Oh, that's
I still
fantastic.
play.
I love that. I, my parents, well, my mother would not let me play American football because we had a neighbor 2 doors down whose son broke his leg and he was 2 years older than me. So my mother was just absolutely convinced I could not play football. So, soccer was it. And so we soccer, soccer, soccer. Well, then, I parlayed that into being a place kicker in college. And because at the time that I was entering college in 1983, there were very, very few scholarships available for soccer players and stuff. And so,
Yeah.
yeah, no. So I got over the soccer addiction after playing American football because in my mind, soccer was just a good reason to run for 90 minutes. And I didn't think that was very funny.
Yeah.
So I applaud you as a 73-year-old outscoring goals and stuff like that. So are you more of a striker, a midfielder, a defender? What do you do? What's your
Always
job?
been a striker, always
Okay.
played number nine, center forward, always.
Okay, always. Well, that's what my boy was. Had the speed and had the accuracy. So that's great. Well, that's good. Good to see that. Okay, so a lot of people they know me as Rex, that energy guy, but actually the first company I ever started was a paint contracting company when I was 17. And being just a curious kind of goober that I was and still am, kind of a tech guy. It wasn't enough just to put sling paint on buildings. I wanted to know what the chemical makeups and why things worked and percentage of what actually, after the water evaporated with latex and things, is what was left. Okay. And then also some of the reflective products. So I want to get to that in a minute, but I would like you to take a high level explanation of your two main products, the coat zone or the coil coatings, and then also your thermal block, and just sort of give us a high level on those. And then I want to deep dive a little bit on those technologies.
Okay. Well, the products actually came about because if you want to reduce energy as it relates especially to HVAC, there's only three things you can do. You can buy cheaper electricity, and I'm not in that business.
Yeah.
Or you improve the efficiency of the unit, or you remove the imposed thermal load. Those are the two things that we do with this particular product. So the coil safe product is a product that we apply to the coils of air conditioning or refrigeration in order to protect the coil from corrosion, fouling, and also any type of microbial contamination. The coil of an air conditioning is the heart of the air conditioner. Its basic function is to transfer heat. And if it cannot transfer heat, then the unit will not be efficient. It will not do the job. So we apply the coil safe. It's a very thin film coating that we actually spray onto the coil. It adheres via a covalent bond, so it's not like paint, it won't chip or peel. And it's also antimicrobial, so it will not allow the growth of any bacteria, mold, mildew, or anything like that. And we give a 10-year warranty on the product. Manufacturers like us because with our coating process, we never break the refrigerant line or any solder joints, so there's no potential for any warranty claims. And whenever we coat the unit, we don't just coat the coil, which most coating companies will do. We coat everything. We coat the exposed copper, the header, the flywheel, even the fan blade we can coat. So that's our core coil product. But whenever COVID came along, we do a lot with military hospitals, especially. And
Okay.
they wanted to know, could we take it to the next level? Instead of being passively antimicrobial, could we make it actively antimicrobial where it would attack and kill the virus? And Russell, our CTO, who is, we call him Mr. MacGyver, he's always playing around with things and experimenting. He worked with our chemist, and we added a silver ion nanoparticle and created what we now call Coil Safe Plus. We sent it out for ISO testing. We had a 99.5% kill rate on bacteria, 99.8% kill rate on live COVID. So now that product is widely used on indoor coils, evaporator coils, by hospitals, government buildings, schools, in order to protect that surface. Once that product is on the surface, it has an active kill rate, so anything that lands there will be killed. And
Hmm.
that way you are protecting the coil from any type of microbial contamination.
Wow.
And then our third product, which has just gone crazy, is called Thermoblock. And it is what's called a radiant thermal barrier. So most people understand insulation. Insulation has an R value, which means it will resist heat to a certain point. And beyond that point, the heat will pass through. Our product actually rejects heat. It will not let heat load onto a surface. However, the problem is it's very hard to prove that because you can't really get a proper R value for a coating.
Right.
So we ended up going to the biggest lab in the world, Intertech Labs, and we said, what's the test we need to do? And they said it's called a heat gain coefficient test. They use it for actually doors and windows.
Hmm.
So we prepared our samples, sent it off to their solar lab in Fresno, California. They did their testing. They verified we reject 93% of solar heat gain. So we use it for a variety of purposes, and it seems like every month there's a new application for this product. Initially, we developed it for the cabinets of rooftop equipment, ductwork, for the actual roof itself, and also for where you have steam pipes or chilled water pipes. Often you get condensation. Our product will eliminate that condensation. But beyond that, now we have crazy applications. Here in the Philippines, about 4 weeks ago, we were approached by the Philippine Army. They have these massive trucks that they drive, and they're not air conditioned, and they're like sitting in an oven. So we just coated the cab of one of those trucks. We lowered the temperature by 20 C,
Wow.
and then they painted over it with their green paint. But they have then taken that to do testing, but they are very, very impressed by the fact that we're reducing the temperature that much. So those are our three core products. And as you know, we're in many, many countries around the world, and it seems like, the more we talk to people, the more interest we get in our products.
So I want to go back in a little bit of geek speak a little bit here, and I hope people are going to understand that. So when it comes to where this really makes a big foundational change, because it may not be as visibly sexy as like an optimizer or solar or things that are like wow in your face, but this is fundamental because heat transfer or avoidance is key to the energy conversation. If you take just the heating and cooling of the airspace in a building, that's about 60% of your of your energy draw, whether you're using gas, thermal, whatever it happens to be. So this is very, very impactful and it's very important. But so yes, if you're listening, this is where it fits in, guys, is because we're helping manage heat. And I'm going to come back and talk to you a couple things. But back to you talked about in the coil safe that it's different than paint as far as it's how it adheres. Is this sort of like a latching on, again, without, giving away trade secrets? Is this
Yes.
like latching on to the ions of the external surface of the copper?
Correct, because if it's a polyurethane or an epoxy, it basically adheres via London force adhesion, which is how any paint adheres to a
Right.
surface. It just grips on. This is exactly what you're saying. It shares an electron, and the ions combine so that it actually becomes part of the metal. It will not chip, it will not peel. In fact, our coating, a blowtorch will not take it off. It will withstand up to 1000 C. So it's a very, very durable coating.
Okay.
And it's also the other nice thing about it compared with a lot of the other coatings. In the airstream now, there's a lot of legislation in terms of what is allowed in the airstream. And one of the important factors is we are zero flame, zero smoke. So we
Okay.
can be in the airstream with no issues.
Interesting. Well, I knew a little bit about that, but I wanted to really make sure people understood that this is actually like it is bonding with the metal. It is not, and like, a paint will chip. Okay.
Yep.
This stuff. Okay. So fantastic. So that makes sense. Now, is that the same on metal surfaces like it? Well, okay. Skipping over to thermal block then, are you using the same type of technique to adhere to be part of that
No.
ion?
No, no, thermal block cannot adhere via a covalent bond. It's just
Okay.
adhering like any other paint.
Paint.
So you have to make sure the surface is clean and dry and has a profile in order for the product to take. And the thermal block itself, it starts off as a water-based acrylic, and then there's about 37 other ingredients in that
Okay.
compound. But as such, it's easy to work with because you stir the bucket, you can brush it, roll it, spray it. Very, very simple to work with.
Okay. So then that leads to my next geek questions, just because I might be one of the only few painters in the world who ever got to this level. But pigmentation is generally delivered through what is called titanium dioxide. And titanium dioxide is your pigmentation level. So it's the white, and then you add tint to it.
Hmm.
But that also has a reflective value to it. Okay, as minute. I'm going to assume then, or can you help us understand that what you're doing with thermoblock is because you can paint it, is you're doing something different than just traditional coloration of the product with titanium dioxide.
Yeah. And almost every month we come across people who say, "Oh, we've found a product does exactly the same thing." We say, "Oh, really? It does? Where's the testing on this?" And normally there's no testing. It's a bit of a joke because thermal block addresses heat in two different ways.
Okay.
So whenever you think about heat from the sun, most people think of the actual light which strikes a surface. Any white paint, anything white, will reflect that light. But that light only represents about 30% of the heat gain, which is
Okay.
why if you have a white car sitting outside with a black car, yeah, the black car is going to feel hotter, but the white car is still going to feel hot.
Yeah.
So the key to rejecting heat is addressing the IR, the invisible light. So what we look at is what's called the emissivity of the product, and that is the ability for heat to load onto a surface. So our product, whenever it was tested, has a very high reflectivity, but equally important, has a very high emissivity. It will not let the heat load onto a surface. And how we demonstrate it in a very simple little way is we take a metal strip with a small piece of thermal block in the middle, and we'll hold that strip in our hands, and we'll take a blowtorch and we'll make the other end cherry red, and no heat will ever pass to your hand. It's
Wow.
a pretty mind-blowing demonstration that we do.
So in a sense, then it's sort of bi-directional, right? So it's doing that emissive blocking on the underside, whatever's touching the surface, then on the top side, correct? Is that accurate then?
Yeah, yeah. In fact, if you turn that same little strip of metal over, I'm saying, to the on-coated side and you heat the top of that, no heat will also pass to your hand because it totally protects right around that piece of metal.
Wow, that's really cool. Well, I'm really glad
Yeah,
we
it's
we
pretty
went
mind-blowing.
to talk about that because when I first met you and we were talking about applications and me being around youth sports so long, I mean, and being on sidelines where, you'd have a Fahrenheit of 110, 115 degree artificial turf. And then you have, benches and bleachers and all those things. And I thought, that was the first thing came to my mind is let's code all that stuff, right? Because
Yep,
you're standing on a turf sideline and you step over and sit down on a bench that might be 20 degrees hotter. So 135, 40 degrees. Ugh, but
easily,
yeah, easily.
easily.
Yeah.
In fact, we did a job in Saudi Arabia. It doesn't get much hotter than there, and
Ugh.
this was for Johnson Controls, one of the big giants in the energy world. And they said to us, look, before we test your product, you come to our office in Riyadh, our sales office, and you show us this stuff really works. So they took us onto the roof, and you could not even put your hand near the surface of that metal.
No.
We coated the coil of their package unit, we coated the cabinet, we coated the ductwork. Afterwards, everybody in that building came up and laid their hands on that unit because it felt cool. They also put a data logger on prior and post, and there was a 12% energy savings from just doing the coating. So
Wow.
it's very, very, very effective.
Yeah, and once somebody gets their mind wrapped around the technology, the applications are practically endless. And because you
Yeah.
do your adheration different than what you do with coil safe, any surface could be coated correctly or pretty close to any surface as long as you can get it clean.
Yeah, we have coated cement roofs, we've coated tile roofs, metal roofs, we've coated plastic, fiberglass. But one of the applications we were doing was in Saudi Arabia, they have every home has these big tanks. They're normally plastic or fiberglass on the roof to hold the water because water supply is not very reliable. But in the summer, you can't take a shower because the water is actually almost at boiling point.
Too hot,
So we
yeah.
started coding, yeah, we started coding some of those as an experiment to see how that would work. So pretty amazing the applications for it.
Oh, that's amazing. Yeah, the more we talk about it, the more my head spins about the application. And so when you and I have talked before, as we've done, proposed business and things before, is um, any surface that you can create barriers around. So let's talk like let's say a rooftop unit, so an RTU for an AC. It's not only a good idea to use thermal block on the cabinet, but you probably ought to get a perimeter around that. So could you expand on that a little bit?
Yeah, that's a very good point, actually, because if you're coating the cabinet, you're rejecting the primary heat hitting the actual cabinet, but then you have heat hitting the roof, which is bouncing back up onto the cabinet. So if you do like a 3 foot square around the base of the unit, you're going to take that heat which would come from the roof and remove it, which will again improve the efficiency of that unit.
So what it does, like your name, it creates a zone of heat reduction around that. Now, have you done this on complete roofs then? As people said, okay, now let's go all the way and put it across the whole roof?
Yeah, we've done commercial and we've done residential. In fact, I'll tell you a very funny story. We did a roof here in the Philippines, the home of a engineer. It's a metal roof, pretty big home, and we coated it. He was ecstatic because now his house felt a lot cooler. But 2 months later, the utility company here in Manila called Meralco came out to check his meter because they thought he was stealing power because his energy bill had dropped by almost 20%. They actually asked him, "What did you do to achieve this?" And subsequently, we are now doing, week after next, we're doing a test at one of the largest data centers here, coating a 200-ton chiller with Meralco being present because they now want to endorse our product to their customer base because they're looking for energy efficiency applications. Because here in the Philippines, the demand for electricity is greater than the supply. So they're
Yeah.
looking for anything to cut back on energy. So yeah, we have done many, many, many roofs, metal roofs, cement roofs, rolled roofs. Yeah, doesn't really matter. The only thing we wouldn't do would be like an asphalt shingle roof.
Yeah, that's the one thing I've thought about that because it would be impossible to really get that to a clean surface that you could get even adhesion. I mean,
Yeah,
sure, but you would never be able to attain that. But no, that's
yeah,
amazing. And people don't think about it. If anybody's read my books, I always talking about the four pillars of energy and the energy conversation. This really is in that second pillar of conservation technologies. And it should be
yeah,
something that someone should consider as part of their deployment of any of these technologies. Because if you can get heat is the worst enemy of electricity. And it affects motors, it creates a resistive loss, line loss. And so anything you can do to reduce heat is a really good way to part of your strategy. But the problem I see in the marketplace, and I know you've seen this too, is there a lot of people out there posing what they think are similar technologies and making claims that are unsubstantiated. And you guys have gone to that extra level to get the testing done. And I think that's something people need to really understand. I mean, when did you guys sort of have that clarity to say, we've got to take it? Was it just one or two engagements, or did you have some vision to say, we've got to separate this thing out so it doesn't look like, the wannabes?
yeah. I mean, we had initially done a fair amount of testing because we realized if you're going to go to very large companies, that's the first thing they're going to ask for. But another thing happened that it sort of put us in a position where testing just made more sense. That thing was called COVID, where we were
Yeah,
shut down for virtually 2 years. And we thought, what are we going to do? Well, we might as well spend our time getting additional testing done. So we ended up doing like 3 year weathering testing on our product and a bunch of other tests during that period of time because we knew we weren't going to be selling very much. So we
right.
used the time valuably. Yeah.
Oh, that's great. That's great. I just love your guys' technology. I mean, this is one of the best kept secrets, and hopefully, working with us at Energy Suite, we can help get rid of this as an unkept secret and a secret that not as many
Yeah.
people.
One of the biggest applications we have found for the product is on ductwork, where you have ductwork running across a roof. Traditionally, you're going to have insulation on that ductwork,
Hmm.
but everywhere in the world we've gone, we've seen you're going to eventually get moisture content. Once you
Right.
get moisture content, the effectiveness of that insulation is gone. So what we normally do is if the insulation is failed, we take it off and we put our thermal block straight onto the metal ductwork, We are more effective in producing the cold air. And what we're doing is we're creating not only a thermal barrier, but equally important, a vapor barrier. So
Right.
it's a long-lasting alternative and likely about 40% of the cost of traditional insulation.
Well, and see, the problem I have with insulation is you can almost virtually never get an even application of it. You can't get a
Yep,
surface seal. Okay.
yep,
So you'll have people have these phase change, material shields, good stuff, but you don't have every surface completely sealed. You have people who have even some more than more advanced multi layer in insulations and things. But if you don't have a complete seal, you know, you're doing good. I mean, there's always good to that, but you don't have the effectiveness. And so that really makes sense what you're saying. And okay, remove the insulation and then
yeah,
create the coated surface because then it's sealed. Because
yeah.
if you can 100% seal it, and I'm sorry, folks, sealing tape is not what I would consider, seam tape, thermal seam tape is not what I would consider sealed.
No, and that is really the biggest problem. It doesn't matter what you do in terms of insulation, because you've got the flanges, you've got all the different joints, you'll never get a completely watertight surface.
Exactly.
So moisture will get in, and once it gets in, you're finished. And we find the same thing, for example, with pipes, chilled water, and in fact, it's quite funny. Chilled water and steam pipes here in the Philippines, we've looked at so many different buildings. So they put this nice insulation around it. Then they take this tape and they
Yeah.
wrap it as tight as they can. And in wrapping it tight, they've destroyed the insulation. The insulation is supposed to be this thick. They wrap it so tight, it's now this thick. There is no insulation. Then they wonder why they get condensation.
Well,
So,
and then you can never get it. I mean, that's like building a house out of duct tape. I mean, you can never get
yeah.
it sealed 100%.
You can. A funny story. Whenever we first went to Saudi Arabia, we met a company there called Al Shira. They manufacture ductwork. They thought Russell and I were the equivalent of Laurel and Hardy whenever we arrived there because they literally laughed at our concept. And they had a run of ductwork with fiberglass and aluminum cladding, which is about as good as you're ever going to get. They had another run beside it where they hadn't yet fabricated it. They took our product, they put it on, and according to their testing, we were 16% more efficient in producing the cold air, and we were about 40% of the price.
Yeah. Yeah. My son is in HVAC, and I've been telling about him. I'm like, look, Beck, on new construction for even just residential on your runs, as far as your ductwork runs, this would be great because you would seal it off. And he's like,
Yeah.
oh no, but we've got tape, we've got these tapes. I'm like, no, 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 no. So in new construction, if you're going to build an efficient home, you would as soon as you get your runs in, you would just coat all of that because you would
Yeah.
actually have a full seal on stuff rather than the partial. So let me ask you another geek question, and most people out there won't care. How thick does a thermal block of application need to be? Is it in multiple layers? I mean, what does that look like?
Yeah, we want to build to about 150 microns, which is about 8 point something mils thick. In order to get to that, you're normally looking at about four coats to hit the 150 microns. The first coat is always a very light coat. You just want it to tack on the surface. So it's a very light dust coat. And then you'll build likely another three layers to hit your 150 microns. But it's a very solid product, but it's about 65% solid. So it
Okay.
dries very, very quickly. If we would start at one end of ductwork, by the time we get to the other end, the first part would be dry and we can go over it again. So dries very, very quickly.
Very quickly. Okay, so that makes sense because when you and I were talking before on some particular applications outside of just the conversation we're having today, I was like, okay, but you're going to put paint over it. But if you're putting the paint over it, then that's really not impacting. the thermal block capabilities. It's not impacting that because you already have that base under it, and so the paint's just um, it's like window dressing, I guess, or lipstick.
Yeah,
Yeah.
yeah. Yeah, and
Okay.
sometimes you have to do it. We're looking at doing a project here in the Philippines with a university called Adamson's University. And for some weird reason, every roof they have is this bright blue. So we're going to coat, let it cure for 3 days, and then paint over it with the blue paint. As long as it's a water-based paint, we can do that.
I remember the day here, I grew up in Colorado, and I can remember when they made a big issue out of painting the roofs of the school buses
Yeah,
white, so it would be cooler. I was
yeah,
like, I still know people over at the county. Maybe I have a conversation with them because this is more than paint. This would actually do something because, the AC capabilities of a school bus are terrible. It's
yeah,
just terrible.
yeah.
So,
Yeah. Well, funny, Russell, our CTO, had a friend who had an RV, and in the summer he was having problems having the AC keep up and keep the RV cool. He put the thermal block on the roof, and he said, "No, I don't even need to use my AC as much, and in the summer, no issue whatsoever." So it really makes a difference.
that's great. I love the technology. I love what you guys have, and it's really important. We're happy to have a relationship with you and looking around the world with ways that can pull this out. So it's really been good to get you on today and talk about the technology because people read brochures, they watch a video, whatever. You don't actually finally get into I guess, the stories that matter and stuff like that. So, really want to appreciate you to take the time to come on. Is there anything else on either one of the products that we should share with the audience before we wrap
Yeah,
things up?
couple of things. One interesting sort of side issue that came up on HVAC with one of the big manufacturers. They were having issues with their PCBs, the circuit boards rusting out.
Okay.
We now coat their circuit boards with the coil safe product. So we actually seal off the connector points. And Russell decided, being who he is, to use Play-Doh to seal off the connector points. Then we'll spray it with the coil safe. Once it cures, it has the same properties as glass. It will not conduct electricity, but it will prevent corrosion. It'll also prevent insects, or in my case in Hawaii, little geckos shorting out the circuit board. So we've now started coating quite a number of the circuit
Circuit
boards
boards.
for these air conditioning companies. And the other thing, I want to emphasize, most of the coating companies that are out there are coating new equipment. Because ours is a spray-on process, we're
Hmm.
not only just coating new equipment, we're coating existing equipment that's already out there.
Right.
Last year, Russell did 40-year-old air handlers in Ben Taub Hospital, which is the oldest public hospital in Houston. And he did that in a live working hospital, coated those air handlers. They were going to replace them till they saw the price, and then they refurbished them. And he was asked to go in, and we coated all of those air handlers in a live working hospital. So very, very, very practical in terms of the application of the product, even in a live environment like a hospital.
That's a really good point. We all have these ambitions of making our homes or buildings more efficient. But when you look at the cost, sometimes it's prohibitive. So more and
Yeah,
more people are doing the stay and fix rather than replace because it's very expensive. So that's a really good
yeah,
point. Really good point.
yeah. And if you live anywhere in a coastal area, you're crazy if you don't get your coils coated to
Yeah,
prevent corrosion, because the first thing that's going to go on your air conditioning unit is the coil.
yeah.
And without the coil, you don't have anything. So you want to try and protect it.
Yeah, people don't realize how corrosive it is. One stop along the way in my career, we moved down to a software company that was based in Melbourne, Florida. And, a lot of the paint companies do their testing in those environments just because it's so corrosive. There's so much humidity and stuff. And so when we moved into our house, my mother came down and she bought as a housewarming gift for us a metal swing set. So I didn't think anything of it. I'm from Colorado. Metal swing set will last for a long time. So I'm out there installing it, and my neighbor comes over and he says, "You're not from Florida, are you?" I says, "How do you know?" He goes, "You have a metal swing set." And I says, "Oh, come on." He goes, "No, that'll be good. That'll rust out very quickly." Well, we were only there 26 months, and we threw the swing set out, and we were
Yeah.
eight miles in from the
Yep.
shoreline. Okay, so we weren't
Yep.
sitting. It wasn't like the houses on the beach, in there. It was.
Yep.
We were 8 miles in, and literally the only things that we took from that swing set were some plastic parts that I could use later on a slide. And so
Yeah. Yes.
anybody that is anywhere near any coastal environments or heavy humidity environments, they're insane not to do this because your asset protection you just get eaten alive. And people don't think about that.
Yeah. Yeah. That's exactly right. That's exactly right.
Yeah.
And again, that's why our coating is so popular because it prevents the corrosion. But unlike other coatings that go on thick, it's not affecting the heat transfer. Therefore, it's not lowering the efficiency of the unit. You'd be pretty disappointed if you bought like a 20 SEER unit and then you discover you put a coating on it, brings it down to 15 SEER unit. That's pretty disappointing.
No,
Uh, but that's what can happen essentially with coating. You're putting on thicker coating, you're reducing the heat transfer, therefore you lower the efficiency of the
lower the
unit.
efficiency.
So
That's great.
ours is only 8 microns, so it's very, very, very thin.
Very thin. That's awesome. Anything else did we not cover? I mean, I want to make sure that this time together that we get people educated the best as possible.
No, I think that's pretty well it. There, I say there's always more and more and more application. Oh, one other little side issue with coil safe. We had a friend of Russell's again who had a metal boat, and you were getting the crustacean on the boat and all that stuff on the bottom. So we said, no, ours is antimicrobial. It'll really help. If you want to clean the boat, it'll be very simple. Literally, you could take a plastic knife and get everything off it. So anyway, he did it. He said, yeah, it's fantastic. It keeps the boat really clean. He said, but I'm going to tell you something else. My boat is faster. Because of the glass-like surface, you don't have the same friction and resistance. So his boat was actually faster as a result of putting the coil safe on because it is a glass-like surface.
Yeah, it's fun. This is one of those technologies. It's a lot like the optimizers that we work with. The more you think about
Yeah.
it, the more places you can use it and impactful. So
Yep.
anyway. So folks, if you want to get more information, just real quick, go to coatzone.com and take a look at this. You have dealers across the country, across the world. You guys work in all different industries and stuff. So yeah, please do reach out to Stuart and team there. They're fantastic. And Russell's a good egg. I've had meetings with Russell on Zooms and stuff. So I can't tell our audience what a better group to work with, and so it's fantastic. So we'll close out like I always do, and I have this loaded question for every guest, and I always pray that not everybody comes prepped for this because it's a good question. So I did an interview years back, a podcast interview with this guy. He called himself the bucket list guy. And he's actually over in Australia. Really nice guy. So we all have this concept, or we've learned of this concept called the bucket list of, things we want to do before our time is through, blah, blah, blah. Well, there's always an opposite, a yin and a yang in the world. So there's a bucket list of things we want to do. And then there's one that rhymes with bucket and starts with an F, but this is a family show. That's the F it
Yeah.
list. What are the things I never want
Yeah.
to do, right? And so I
Yeah.
always ask my guests at the end of the show, what might be on one of your F it list items, things that you would never want to do?
The idea of jumping out of an airplane with a parachute is not something that I ever want to do. It may be thrilling, but no, thank you. It's not something I want to do. I get have nightmares thinking about it, just jumping out. So that would definitely be one.
That would be one. For me, whenever we saw that Indiana Jones movie where he falls into the pit, all the snakes, that's something I would just be, I probably could launch myself vertically to get back up because that's,
Yeah.
no, anyway. Well, thank you, Stuart, for investing in time today. We always love working with you and supporting what you guys do around the globe because I love your technology. And it's always fun to connect with people and good stories. And so, you need to report to me next time we connect. After your next set of games, how many goals you've been scoring over the last little bit? Because now I know that you're a striker now. I gotta be holding you accountable.
Well, I won't get playing till I get back to Hawaii, but I'm looking
Yeah.
forward to it. So
Okay, fantastic.
great. Well, I
Well, folks,
appreciate you having me on, Rex.
yeah.
It's
So
been
always
fantastic.
take the time. Thanks for listening or watching today. Make sure you subscribe and hit the notifications buttons and comment. We always love the input. And if you have ideas for people we need to talk to, please always do that. And so until next time on our next episode, I will say what I always say. Thanks and make it a great day.